Hi everybody. I hope everyone is doing wonderful as always. Today we will be solving this question from LeetCode, which is a symmetric tree. So let's understand the description first. The question says, given the root of a binary tree, so we have given a root of the binary tree here, as you can see in the function tree node star root. Check whether it is a mirror of itself or symmetric around its center or not. So there is an example given here which has a root of 1 and then it has a left node of 2 and then the right node of 2. 2 has a left node of 3. 2 has a left node of 4 and then the other 2 has left node of 4 and then right node of 3. So let's understand what is meant by symmetric tree. I have sketched the same problem description or the same example from the lead code in here. So I'm going to be showing here so that it is easier for you all to understand. So we basically have to check if this tree is symmetric or not. So what does it mean by symmetric tree? Well, in the question it says that it has to be a mirror of itself, right? So when you look at your face in the mirror, you can see your face over there, right? So it is called a mirror. Now the thing is that it is this tree has two branches here, left and then the right sub tree, right? If you kind of see it like this. Now, if you see these two is forming a mirror with this two, so that is symmetric. And then now this three is forming a mirror with this three, that is also symmetric. And now this four is forming a mirror with itself, that makes it a symmetric tree. So this is our symmetric tree, right? And then it is also saying true in here. Don't confused, because when you compare these three and these three, you might think that three is not being mirrored with itself, but the thing is that it has to be mirrored through the center. That's why these 4 and 4 should align, and then you can think of these 3 and 3 will also align. So that is basically the idea. Now how do you achieve this problem? How do you solve this problem? Well, it is not that hard, but it is hard to get the idea first and then hence derive the problem, right? Well, let's try to understand it here. Initially, you will check if your roots left node and then the right node are same or not. If they have a same value, so you will compare here. If you will compare it like this, if your uh, roots left value is not equal to roots right value, then you can simply return false from here. I'm just writing this statement in here because that's basically the idea, right? Because we have to compare these two, because these two are mirror. If these two nodes are mirror of itself, or if they are symmetric, we can simply compare if they are equal or not, or we can simply compare if both of those values are equal or not. That's what we're doing here. We are checking if the root is 1, right? If the root's left value, which is 2 in here, is equal to right value or not. In this case, so this statement doesn't execute, but we have to check this condition, and this is the a pretty solid check that we can put at the first. After that, since this doesn't meet, that means we will have to check for this three and then this three, right? Because those two has to be symmetric. Now how do you call your function to check those? Well, if you simply see it here, you are at this level, right? You are checking this left and then that this right tree. After successfully checking that, you will call your function. Let's say you have a function, let's say you have a function definition right here like this, and then you will call your function and then pass your left is 2. You will simply pass left's sorry you will simply pass left's left value itself. What I'm trying to say is this is a left value, right? This is a left value of root. If this is a left value, it also has a left value which is 3, right? And if this is a right value, it also has a right value of 3. So I'm trying to call my function. I'll define a function of any one type. You you can see that. But I'm trying to call a function with two parameters, and then I'm checking if my left's left value and then my right's right value are equal or not. So if my right's right value are equal or not. So that's the idea. So I called for these three and then these three, right? Because left and right are here. So I'm calling if left's left value and right's value are equal or not. And then now from that we can define a function like this from here. So our function can be function which is basically a tree node star itself, which accept left tree and then the right tree. We can write right here. So this can be our function, right? Now just by checking that your condition doesn't meet, you also have to check for these two if these are also equal or not. When you check these two, the left's left value and then the right's value, you have to use ampersand operator and then call your function again for your left's right value and then the right's left value, right? So you have gotten left and right here. You are checking left's left value and then the right's right value. If this condition doesn't meet, this condition will be true and then this function will again be executed. So we will check here if my left's right value, which in this case is 4, comma right is 2, and that's left value is also 4, right? So we'll say right's left value are equal or not. So these two functions will be responsible to check our symmetry, and we will simply return the function from here or whatever the value it gets returned from there. Now you have some of the base cases. So the code is these all. This is pretty much the idea, but you have some base cases to handle. So let's say you called a function when you had 3, and then let's say because 3 doesn't have anything, it has null, and let's say 3 doesn't have anything, you have null here, right? Now when you call a function with null and null value, you haven't checked anything for that. So my argument to you is that if you have null and null here and which is asymmetric, does that mean it is symmetric or no? Yes, because both of the values are same. It is just like checking these 3 and 3 are equals or not. Yes, it is. That's why these null and null values are equal to. So we can check it here that if our left equal to null pointer and right equal also null. I've just written null here because of the space. Then in this case, you can simply return true here, right? True there. Okay, that is the idea. Now you also have to figure out one of the base case that is still missing, and then I'm going to show you it from the lead code example here. If you can see it here, this tree looks like symmetric, but the thing is that it is not symmetric. That's why it is returning false here. So what is basically the error here? Well, if you see it here, one called its left subtree, which is tree, and then called its right subtree, which is 2. 2 and 2 are equal. Now, 2 has a left of 3, which should be on this side in order to be equal, but it has null value. And now this 2 has a right of 3, right? So that check was this basically. Left's left and then right's right, right? This is same here. Left's left, right's right, which doesn't match because null, it has a null in this side but value on this side, so that doesn't match. So that can be written as this: if at any point if your left is equal to null or your right equal to null, if either of those conditions satisfies, then you will simply return false from your function. Why is that so? Well, it is because if only one of the condition matches, if this is null but it has a value, it doesn't matter because or only checks for one truth value, right? If this condition executes, it doesn't matter whether it gives false or true. this is true, since this condition meets, then this statement will be executed and then will return false from there. So that is basically the idea. So that's it. Now if you want me to dry run this problem, I can dry run it easily and then show you all. So initially I will call my function like this, from this is the tree, right? So I will call a function here. Let me draw it with this example. So initially this is the code that I have written. So now this is the dry run part. So I will call my function like this. I will get my left value and then the right value from here, right? Which are basically 2 and 2. And then I will check if both of those values are equal or not, right? From here, the condition, base condition doesn't match, and this condition doesn't match, and then I will call a function. I will call two functions from here, which is this one and this one. In the first function, I am calling my left's left value, which is 3 in this case. 2 is a left value, and then left's value is 3, right? And then what is the right value? A right value is right's right. So right value is 2, its right value is 3. So that is the function call. As soon as I call this function, I will go in the function and then check if 3 and 3 are equal or not. Or I would say I will check all of these conditions and then nothing returns anything. So I will go to this return statement, or I'll go to this function call again, and then I will make a function call again for my left value. For 3's left value, it is null, and also for this 3 is has come from the right, and then it also has anything, it doesn't have anything too, so it will also give me null. Now if you see it here, if my both left and then the right value is null, then I will return true from there, right? So this function call will be popped out from the stack, and then I will return true. In this case, I have true stored here. And that was the function call for the left part, right? But I also have, that was for the left part, I also have it for the right part, which is this one, which hasn't been executed. Now what is the 3's right value? 3's right value is null, and if you see it here, 3's left value is also null, right? And that would also give you true. Now since this also gave you true and this also gave you true, from both sides this ampersand operator matches, and then this function is currently holding true value, which was called from the function, this function, which was basically 2 and 2 value, which was called from here. Now it is holding true. Now let's go and check for the right value, right? Or the another function call. These two has been successfully matched. Now I will again call the function, which is calling with left's right value, which is basically 4, and then this is the right's left value, right? Right's left value, which is also 4. Now this will also give you the true statement, same as like this. Since both of the function returns true, true and true becomes true, and then we will return true from here. If that returns true, it will also return true for its main function call, and then our answer will be true, and then we will return true in our answer. So that is basically the idea. I hope you understood the problem. If not, you can see this again, rewind the video and watch it carefully and slowly, and then try to dry run it yourself. It is not that hard, it is pretty easy. Once you do it 1 2 3 4 times, it is going to be very easier. And also do the spaced repetition, because that is one of the most powerful thing that humans have ever discovered. Spaced repetition can help you understand anything. What I mean by spaced repetition is that if you understand something today, it feels like you understood it, and then it feels like you will never forget it. But after 1 2 3 4 days, your mind will be involved, or your mind will get different things, and then you will start forgetting the things that you have learned. So you have to repeat after learning 1 2 3 days. Let's say you learned something today, right? If you don't remember or don't do anything tomorrow, it doesn't matter, but try to do it without seeing the problem again the other day after tomorrow, or after taking a break. So that is all about the spaced repetition. Let's jump over into the lead code and then try writing this code, and then let's submit it. Well, we have a is symmetry function which only is composed with one root value. That's why we will define another function which basically takes a symmetry, and then it is going to get two values, which is roots left and then roots right. And let's call the function from here, take symmetry, and then we will pass our roots left value and then roots right value. Okay, let's go here, and then initially let's check our value. If left value is not equal to a right's value, then that means our tree is not symmetric, and we will simply return false from there. If that execution, if that statement doesn't execute, we will have to call for the following statements. So we will call for left's left value, and then our right's right value, and then use our ampersand operator to call for again remaining two values, which is basically left's right value and then right's left value. If you haven't understood this assignment, I'm basically standing at 2 and then calling 2's left value, which is 3, and then right's right value, which is 2's right value, which is 3, right? Basically, we are comparing this 3 and this 3. And then in the another statement, I'm comparing left's right value, which is 4, and then the right's left value, which is 4. So this is central to the symmetry. So that gets checked there. And then I will try to not forget the semicolon too, and then I will also write a return statement from there, because this is the function call, and then whatever the function returns, we will return that to the main execution. We're gonna have to check for the base cases, and that is if our left value is null pointer, and then if our right value is also null pointer, then in that case we can simply return true, which simply states that both of the trees are symmetric, or the both of the nodes are symmetric. But if at any point if left value is null pointer or right value is null pointer, if either of those condition returns true, then we will also return true from there. So that's basically the idea to solve the symmetric problem. And let's also return from here. Okay, I hope I did everything right. So let's try to run this problem. And then if we get any error, we can simply see what's the error. So we didn't get any error. That means I think our code has been successfully ran. Now let's try to submit the code. All right, so the code also has been successfully submitted. You can check it right here. So that is it for today's video. You can rewind the video if you haven't understood anything, and then try to solve this multiple times, and also try to dry run on this example 1 and example 2. You can simply do the example 2 because example 1 has already been done in this video. You can simply watch the video and then try to do with example 2.